Hey guys, so I came across this continuity problem last day, and I figured I would share it with all of you because it is pretty cool. And actually, it's a calculus problem in which you don't even have to use calculus. It's just simply using like basic algebra, which I just think it makes it pretty cool because you're using a lot of intuition and logic, and I think that is pretty cool in a math problem. So we're gonna solve it now. So please try solving it at home and see if you figure out any other method in which you can get to the solution, okay? So now this is the problem. We're gonna have a piecewise function, g of x. The first piece is this function right here, a difference of squares over x minus a. This comes into this function comes into play when x is different than a, and we also have that when x equals a, y will be equal to 8, okay? Now, what we need to find here is clearly the constant a. This is what we're looking for. And so now we could try the conventional approach in which we set up a continuity definition and we take our breaking points as the values x is approaching to. So we would get the limit as x approaches a from the right side, you could say. So a from the right side. Now, well, this could either be, this can be this function because it is x is different than a, so that can either be values bigger than a or smaller than a. So we would say x squared minus a squared over x minus a. Now, straight up, you can see that if we try to plug in a in there, when trying to set this continuity definition, well, we would get a denominator of 0, whatever we get on top. Well, we would actually also get 0 on top because we would have a squared minus a squared. So we would get 0. And now this doesn't really work. We can't really do anything in here. So whatever, if we say also the limit, as you know how it goes, as x approaches a from the left side of, the same function, well, we would get an indefinite value equals an indefinite value. So what I'm trying to show you here is that we cannot use the conventional method. So now this doesn't work. Now, pretty cool, what we can do is the following. Now we're just gonna use basic algebra. So this, well, we know we can simplify that. Hopefully you already saw that detail. Now we can say that, I'm gonna write that down here. So we know that x squared minus a squared over x minus a is just simply a difference of squares, and we can simplify that as x plus a times x minus a over x minus a, and we know x minus a, both of them cancel out, and we get x plus a. Now, we can simplify this function or this piece that we have here by x plus a. Okay, so now this would give us something like this. So we would get that in that function we have x plus a when x is different than a. Cool. Now, the approach that I'm proposing here is the following. If we try to graph this piecewise function, it would look something like this. So we know this right here, this is a linear function, right? Because, well, it's got a slope of 1 and a y-intercept, which let's just, by common notation, let's just say it's b, so b is equal to a, or yeah, just so we don't confuse it, I'm going to say that the y-intercept is equal to a. Cool. So this would give us a linear function that goes one by one, so it would be something like this, something like this, something like this, and it goes on. And now the y-intercept would be on a. Now, the thing is, we don't know what a is, so we don't know where the y-intercept is. However, something we do know is that when x is equal to a, so let's say this is a, we're going to define the function as 8. So in this case, we would have a whole, and the function would be, let's say, defined up here, okay? This would be 8, or f of a. So what we can do here, well, if you think about it, when we're trying to make a function continuous with a specific value for a constant, we're just simply trying to put the functions or the pieces together. So in this case, what we can do is, well, we know this point right here, which is the function y equals 8, is also a function. And we know we can get that function, or we can find a way to connect y equals 8 with the linear function x plus a by just simply making those equations equal. And we can find the values when we only have one value that we don't know, or one variable. Now, that means that, or what I'm trying to say is that we need to make this point go into this line. Now we can say that that point is, it will be equal to y equals 8, so it would be 8 must be equal to the equation for that function, that linear function. So we get x plus a. And now we know if we're trying to make these two things together, well, we can only get 8 with this linear function if we plug in a. Okay? So when x equals a, that is when we're gonna get 8 as an output. Okay? Because, well, we know that from our statement. When x equals a, in this linear function, we're gonna get 8. So in this case, we can say that, well, x equals a. So we can say that 8 is equal to a plus a. And I now you see where I'm going. So we get 8 would be equal to 2a. And now we can just simply divide by 2 on both sides. And we would get that a is equal to 4. This is our answer. And did we use any calculus? Absolutely not. That's what I mean that, well, it's pretty cool because this whole solution, it's a pretty simple solution. You're just solving for a value, and you're not using any calculus. So I thought this was a pretty cool problem. Now let me show you the proof that a is actually 4. So in the case that, supposing we have the function, I'm gonna define once again g of x as, we know a would be our y-intercept, which would be x plus 4. Slope is just simply 1. So we know if we plug in, this function says that if we plug in a, which we know is 4, we should get 8. Now, if we plug in 8 as x, because a which is 4 as our input, we would get 4 plus 4. And this is clearly equal to 8. So we are satisfying this condition up here. And that is the proof that a is actually 4. So now I hope you found this problem pretty cool. You can't do anything with calculus in this case. Even though it's a calculus problem, you actually need to do algebra. So I think that is pretty cool, and I just wanted to share this problem with you guys. So I hope you guys enjoyed this video, and see you in the next one.